Starting the recording. Happy Halloween!
Ooh.
Yay! Trick-or-treating tonight will be super fun if you don't blow away.
Well, I thought that's why you brought the little treat.
Oh, no.
Yes. Anybody have any good costumes they want to share about?
You just had it, so
Yeah.
very good, thank you. I still have it.
No costumes?
No.
No, my son, my 19-year-old made a costume
Okay.
for a party.
Okay, that's good. Yeah, I used to get into that. The funniest costume I think I ever did was I was a runner who got ran over by a car.
Oh.
I had this T-shirt that was like muddy from running, and so then I like made tire tracks like on the back of it, and I gave myself a head injury. It was really quite gross. So I like that one. But.
Did anybody think you were really there?
No, they were just like, what is this? And I had to explain it. So at the time I worked this was when I worked at Gersani's, and I took marinara sauce and I gave myself a head injury.
So you wanted to make it obscure, or?
Yeah, no, I was going for it. I was
Okay.
just going for it, yeah. So I think that folks might have been a bit grossed out that I was using the food they were eating as a prop, but hey, I was 19. I had other priorities, right?
That's right.
Anywho, yeah, I'm dressed up today as a tired parent. That's what I am.
So we can be tired students.
Yes. And we're all dressed as tired people. Yeah, well, all I have to do to look tired is just not wear eye makeup. Anytime that happens, invariably someone asks if I'm tired or I'm sick.
I'm thinking, how are we going to look like if we are tired students along with tired parents?
Tired students and tired parents, indeed.
You're
It's-
bad.
it's that time of year. But-
Maybe those.
on Zoom.
All right, how about we make ourselves less tired by focusing on models?
Happy man.
Is that going to work? It's worth a try.
Yeah.
Yeah, this the 7 slopes model that's no longer that scary. We've been working our way through this thing. I think where we worked up to was the idea of effect sizes. I think we hadn't done that part yet. Does that sound about right? Maybe?
I'd have to see the picture.
You have to see the picture.
Yep, sorry.
No worries. So we had,
You look at that
we
thingy.
looked at this, because I remember making a point that we have an intercept of -3, and that's not ideal. And we talked about what t means in relation to p-values and all of that stuff.
Mhm.
And then down here, so this is Stata code. So what I am doing is saving the results of this analysis into an object that I can then manipulate and access and do math on. And then I'm printing that object, or excuse me, I'm storing the results and then I'm seeing what my choices are. So these are all the things that are saved for me automatically. So like when I write this in the code, that goes down below, what it's doing is saving that accessing that number. So I'm creating a new variable right here that is going to hold the residual sums of squares for this combined model, and it knows where to get it because of this E thing. So I'm creating a variable that holds this value because I'm going to need it to do math to create effect sizes. That's what we're doing here. And I also need, this is the mean square for the model, and so I'm saving that as SS full. So what we are doing then are the pieces that are described on slide, let me find it, 29. So slide 29 of lecture 4 is how we can get effect sizes for a group of slopes at a time. So we're doing the pieces of that. Now, before we show you the pieces, maybe I should ask the question, why? Why would I need to get an effect size for a group of slopes as opposed to just one slope?
Dichotomous data, where you have like 2 or 3 different categories and you want to lump them together because they're really one variable, but 3 different ways you're measuring it.
Right idea, slightly not right words.
Okay. I'm tired.
You're tired.
I'm
It's fair,
tired.
it's fair.
Tired students.
Yeah, no, it's fine. I don't expect perfection, but I know where you're going.
Mhm.
So like these 2 variables work together to differentiate the 3 possible groups of this variable. Likewise, these 2 variables work together to create a curve as to how income is predicted by age. And these 3 work together to create 3 different sections of slopes for education. So if I want to know what is the effect of education in this model, I need to know that for all three of these things, like together as a set. And because these predictors are correlated, I can't just take their individual effect sizes and add them together. That math doesn't work. I will come up with too high of a total. So for each slope individually, I might want an effect size, but I might also want them for a group of slopes.
Quick question, just making sure I'm remembering correctly.
Mhm.
If all we had was the high school relationship, would we only have 2 of those with the y-intercept? If I was making a predictive model? So if I had less high school, grad high school, and over high school,
Mhm.
if I was making my linear model just with only the high school portion to make our prediction, would I only have 2 slopes plus the y-intercept, or would I have all 3 of those and the y-intercept?
You want to track the change as a function of up to high school?
No,
Or-
with just the high school relate, so you have like less high school?
Yeah, so this is 2 through 11, and then this is 11 to 12.
Right.
Mhm.
So, but since those are the 3 categories, I would use 2 of those categories with slopes, and the third would not be if I was making a linear model with only that predictor with the categories.
I'm not sure I follow, but each of these are not, this is the only one that's a binary variable. These others are quantitative variables. So it doesn't work the same way as if you had 3 groups and you need 2 slopes.
Thank you.
Okay, I think that's.
That's what I needed to know.
Okay, yeah, so let me pull up the coding of this again real quick.
Oh, because that was, never mind, got it.
No, it's good to review.
Okay,
Because
of how that was set up.
let me find that. 1 second, PowerPoint's thinking about it. Yes,
Mm-hmm.
come on.
Oh, sequential one.
Because of how this is set up, it's the 3.
Yeah, so there's a lot more possible values of education
Got it.
besides 3.
Got
What
it.
we are doing is dividing education into regions essentially
Mhm.
and allowing a separate slope to operate
Because
through
we
each
made
of those distinct
piecewise,
regions.
not what I was
Piecewise.
thinking of.
Yep,
Got it.
that's it.
Okay.
Additional question. So,
Yes.
another kind of the piecewise slopes coding, it's different. It's more like starts from intercept and for example, take a less high school degree, it will be 1 until the end,
Mhm.
and the grad high school is will start from like year 16 and starts from 0 to 1 at the end, like the coding in our homework 4. So I want to know what is the comparison between this kind of codes and the other kind of codes.
What do you mean by the other kind of codes?
So for the column, which is the less high school
Mhm.
slope, there's a negative digits in this
Yes,
column.
the values in this column are negative because they are relative to 11 as the reference point. And so, like, grade 10 is 1 less than 11, so that's why it's negative 1.
Okay.
And then grade 9 is 2 less, and so on.
But the example in our homework 4, there's no negative, which is I don't know why.
Because the lowest value is your reference point. So for example, if 9 was our reference point and that was all zeros at
Yeah.
the very top, okay, then 10 would be 1 because you're 1 more than 9. 11 would be 2 because you're 2 more than 9. And then when you jump to the next column over, okay, you would then have like the 2s going down the rest of that column, and then you'd go up by 1s in that second column.
So the coding that creates these slopes is subtracting 11. Because 11 is my 0 point.
Mm-hmm.
And so that's for the first one. For the last one, it's subtracting 12 because that's the new 0 point relative to where the other slope left off. So one slope gets you to 11, the middle one gets you to 12, and then the third one is past 12. Yeah, you got to do the gestures with it or it doesn't count.
Yeah.
See, this is the part that you're paying for. You know, the YouTubers don't get this extra support of me making random hand gestures. Yeah, I have to be careful though. On Zoom, there's an option where it can recognize your gestures, and I've accidentally like muted myself or turned my camera off or things like that because it thinks it doesn't know what I'm doing. But so, pro tip: don't have that setting turned on if you talk with your hands a lot, like I do. So, okay, does that help answer those questions?
Mhm.
Okay, you have a question? Yes, please.
Yeah, so I was wondering if I would center my education from 12 to 16.
If you change, or do you want to center it at 16 as a new intercept, or do you mean make a new piece that starts after 16?
No, intercept.
Okay.
Because I want to see that how 16, that's going to be the undergrad,
Mm-hmm.
and beyond undergrad, how much difference would it make in terms of income participants would be able to come across with. So if it's 16, so 15 would become my, what was that, 11 here in the case of 12?
The
Just
reference.
zero row.
The reference.
Yes.
Zero row.
Okay, so the reference. So the reference would be 15 then. And then 16 would become my intercept.
So let me put some numbers up here so we can.
Thank you. That makes it easier.
Yeah. Since we're not gesturing hypothetically here, let me get,
All right.
because I'm going to run out of fingers pretty soon. Okay, so
Yeah.
you're saying you want 16 to be the intercept.
Intercept, yes.
Okay, so then that gets, and how many slopes are in your story? Still 3
3.
or 4?
3.
Okay.
Less college, over college.
Yes, yeah. Less undergrad, grad, and overgrad.
Okay. Overgrad, I like that.
Yeah,
That's a
okay.
super grad.
Yeah. So overgrad is the easy
All
one,
right.
right? So overgrad would look like that. Like how
Ah,
many years over grad are you?
Yeah,
What would go in here?
negative.
Well, if this section is covered by these two,
Okay, zeros, yeah.
yeah, so then this would all be zeroed out.
Yes, yeah. Because we are not starting it.
Correct.
Yes.
And so then what do you want this one to mean?
Good question.
Does that one start at 13 in your example?
No, 15.
You want,
I want this to start from 15.
Okay. So then this is the effect of getting your bachelor's degree,
Okay,
like that.
yes.
So it would shut off after that point. And then is this like in my example, the effect of graduating high school?
Yes.
Okay, so
yes.
if you did it that
okay,
way.
0, yes.
Yeah, so then this is,
Right, yeah.
that gets you from almost graduated to graduated. And then, then it stops continuing because this one takes over.
Correct.
So then this one would have to be,
Negative.
yeah, so it would get up to 15. Where is, you want your 15 to be your intercept, right, though, you had said?
well,
Is that right?
I thought you said you want 16.
You want
16 to
16
be
to be,
intercept.
you want 16 to be the
Yeah.
intercept.
What was the term that we used before this intercept?
Okay,
The reference?
Reference, yeah.
yeah, so let's fill that in. So if you want 16 to be your intercept,
Correct.
so then this doesn't work anymore because it needs to leave off at 0. And you still want this to be the effect of graduating college, right?
Uh-huh.
So then it would be like that.
Okay. Okay.
But then this one would have to be, like, if this is just that one switch, then these would all be negative ones. Like that. Because this is the only point that you're interested in, that switch.
Uh-huh.
And then we need this one to pick up where that one would have gone before. So this would be what? This would be -1 relative to that one, and then this would be -2, and so forth, I think. So let me go ahead and fill it in. Okay. I normally don't do this in front of folks, so it's highly likely that I've screwed this up because doing it on the fly is challenging for me. But, so
Oh, I
this
get
would,
that.
this would
Yeah, yeah.
take us to here,
Mm-hmm.
and then this one gets to here, and then this one gets to here.
Question?
Yes.
In column C,
Hmm.
do you, my question is if that whole section being -1 versus starting at 0 at the top because you haven't gotten to the graduation yet.
So the idea is that you're differentiating just this transition point.
Right.
And the values that do it have to be relative to where the intercept is in your model. So I think it has to be -1 because these are all
Okay.
treated as interchangeable.
Okay.
And then, but they're not interchangeable from the overall model because you've got this one operating through them.
Okay.
Okay, does that help?
So
Maybe?
for column C, it's still the binary column, like
Yeah,
binary.
functionally, yes, like it's still just changing in that one spot, but what it's changing relative to is where the rest of the function is operating.
So -1 and 0 is interpretation. It's not STEM.
I'm sorry, say it again?
It's the interpretation in the model.
Yes, yeah, these three pieces are all working together to describe a discontinuous trajectory, essentially. A discontinuous slope is the way I would phrase that. And we need all three of these slopes to fully describe how education relates to income. And if we want to have an effect size to describe how education relates to income, we got to lump the slopes together and get that effect size. But that's something you have to do extra.
Thank you.
Thank you.
Just
Yeah, piecewise models are tricky. I always start with the table like that, and then I write the code to make the table. Like I have to have the representation. You have a simpler example in your next homework based on just two slopes. And the knot point is at 0, so the coding should be more straightforward for that one. Let's see here, this is model 1, far enough down. Okay. We have, I was in the status section, that's where I was, I think, right?
Yes.
Yes, I was. Okay, there we go. Getting back to the thing.
You had the R
Yep.
at there.
There we are. There we are. Yes. Okay. Reminding myself what I'm doing. So getting individual effect sizes, and then I'm saving these from, so these are from the full model. I'm going to need those later on. So to recap, I have saved the result of the model to an internally stored object. I've asked it to print it so I can see what the stuff is called. And so then SS residual is now going to take on that specific number, and SS full is another variable that takes on that number. So the advantage of doing it this way is that this code should work regardless of what your model is. Like you don't have to manually type these numbers and do math on them yourselves because they'll change every time your model changes. But because Stata like stores this value under this label, it's sufficient for you to know what the label is to access it.
So if you did a different model, it's going to replace those E values.
It
If you don't print off that stuff in beforehand or whatever.
Yes, so like this, I'm storing this here so that I can save them, but this is just printing like what my choices are.
Okay.
Yep. And so then this code is creating specific objects to hold those values that I'll then access below. So in terms of individual slope effect sizes, P-core, in Stata provides partial and semi-partial eta and eta squares, R's and R squares, but we would not necessarily want to use them for all of these things. I can also do additional coding to get D's. So like this is the model implied difference between the middle group and the upper group.
Mhm.
That's not given directly, but it is given directly as their difference. So what I'm doing first is estimates restore. You have not seen this command yet. The thing about Stata is that it only refers to like the last thing that you did. So I sort of broke the sequence by doing a different model. So if I were to run this lincom, it would be like, there's no linear combinations possible out of this. What are you talking about? It's like, no, I want you to refer back to the thing I did 2 things ago. If you want to do that, then we store the results so that we don't have to run the analysis again, and then restore means, hey, bring those back into focus so that I can do stuff to follow up on that. And for these models that run in a split second, it's not a big deal, but when you get into more complex models that take hours to converge, like you don't want to have to rerun it every time you want to do something. You want to be able to extract the results and save them. So this brings back the context of what this code should be doing to get the linear combination of the difference. And then these things are all saved objects from the lincom automatically. So our estimate is the estimate that it found, so that number right there. RSE is this number right here. And what is estimate divided by standard error? There's a vocabulary test. It's a letter question. What's estimate divided by standard error? We know that as some other letter.
Cohen's d.
Not this time. We're building Cohen's d. This is an ingredient in Cohen's d.
All right.
You're close though. Estimate divided by standard error. Let me scroll back up to the results.
T?
T, yeah. So the Cohen's d formula has 2t in the numerator. T wasn't one of the things that got stored in my results, but I built it.
Hmm.
What did get stored in my results are the degrees of freedom. So that's the denominator that creates Cohen's d, the square root of the degrees of freedom for the model. And so then I'm asking it to print a label for this, but then it's doing the math using these saved objects. And I did the same thing to create a partial R and a semi-partial R. So this code should work after any lincom. You can just use it directly as is.
Question.
T, very good.
Is the 2 because you're doing the 95% confidence interval?
No, it's just
Is it-
2T.
It's just part, and is it always a 2 no matter what?
Yes, always a 2. It's not tied to anything.
Thank you.
Question.
Yes, why did we use estimate? When you asked about t, why didn't we say coefficient divided by standard error?
Because
I'm
this,
sorry.
no,
I'm getting confused with the vocabulary.
you are not confused. Stata is confused. Because this is what it calls it internally. Like, I didn't choose this label. Like, it stores the estimate as estimate, even though it prints it with the label coefficient.
Okay, it is, okay.
It is internally inconsistent. I know. So if you want to know what you get after a command, like what your choices are here, that is either return or e-return. So you can type that and see, like e-return list, like these are the choices that came after the model. The same choices then are available after this in lincom just for this specific result. And there's only these, like there's very few. T wasn't listed. But estimate is what it calls it internally.
All right.
And in the Stata documentation, so I'm not sure if folks are aware that I have this on the course webpage because that page is very full at the moment. But I do this more for myself, actually, to keep track of things. So under software resources, these are all the different functions and packages that we're using. And so this is a link to the documentation. So for instance, for regress, if I pull that up, and Stata's documentation is actually pretty good. It's meant to be a product that people pay for. So, you know, they have good documentation as opposed to products that are free that don't. But at the end of this, like each of these documents is structured the same way. There's something called stored results. I don't want to ask AI. Stop it. Let me get
They
to
want you to use their new product so they can practice with it.
yeah. So, like for instance, come on, zoom in. Come on, you can do it. Stupid thing.
Mhm.
Nope, that's not it. Where's the zoomy button?
Right
Down
side,
to
right
the
side on the bottom.
Oh, there we go.
Yep.
There we go. Thank you. I said I know there's a zoomy button in here somewhere.
Mhm.
So stored results, like the documentation tells you what all your choices are, and so then this explains what each of those numbers is. So then when you run an analysis, like it's then printing what actually happened. But the documentation gives you the official label for what these things are if you couldn't gain that from the context of what's going on. And there's extra things in here that you folks haven't learned yet, like the log likelihood of the model is in here. That's the adjusted R-square, for instance. And there's other stuff, the individual coefficients are stored in a different place. But this is what the model results can be summarized as. So yeah, and then there's even more stuff. So this is all the stuff that's available to you that can be stored. Okay. So here are then the values that are computed using this code. And because this is structured to work with any LINCOM, you shouldn't need to change it. There's nothing in here that is model or data specific with respect to that. So then if we want to get overall effects, there's a couple different ways to do this. I'm going to show you one way in this example and a different way in the next one. There is a statement in Stata that you can be used after many different procedures called test. And what it does is say, hey, what slope do you want to test and how do you want to test it? So like this one, I say, what if this were 0 and this were 0 at the same time, where the parentheses are used to indicate how many different slopes you're lumping together. So it understands that this is a 2 degree of freedom test because I'm asking simultaneously if each of these were 0, what would happen? And so this is my F value for that request. So it has 2 degrees of freedom because I'm fixing 2 slopes to 0 essentially. This would be the denominator degrees of freedom that remain. That's from the model. And then the F is significant to 4 decimal places. So that means these 2 slopes together are not 0. So like overall, I can say there's a significant relationship between the working class, 3-group variable, and income. More specifically then, the difference that's given here would be one of the 3 differences, and the other 2 are already in the model. So we have a significance test then. I can do the same thing for age, so the linear and quadratic slopes. I'm shutting off at 0 and asking what would happen. And the same thing for the 3 education slopes. So I can get a hypothesis test and an effect size for these things together. This is the hypothesis test part. So F is necessary anytime you want to test multiple slopes at the same time. T is for 1 slope. And T squared is F if you have 1 slope. Now the effect sizes. This takes a little bit more work, unfortunately. The idea is that for each of these slopes, we want to run an alternative model without it and see by how much the model sums of squares go down, so we can see what the contribution of those multiple slopes would have been. So like I am refitting the model without the 2 working class slopes in this case. So I'm actually doing what I asked the test to do. Then I am saving the model sums of squares, the difference between what it was in the full model and what it was in this model as a new object, and then I'm using that new object in these formulas. So then going back here, we're at step 2 in this process. So figure out how much information the model captured without those 2 slopes, and then you can see what the difference is relative to the full model. And so the effect then is what's uniquely available because of those 2 predictors. And semi-partial eta squared is the effect over the total sums of squares from the original data, the empty model. And partial eta squared is that divided by the part that is due to just the error or the effect, so discounting everything else. So these remind you, Venn diagram time. So semi-partial is this one. It's the idea of what did your predictor do relative to everything. Partial is what did your predictor do relative to error. So of the variance that's eligible still that hasn't already been accounted for by other predictors, how much did yours get? That's what partial is telling you. Semi-partial is just how much of the R square is due to this set of predictors. So there's the answer then at the end of this. We would say working class is responsible for 4.2 of the explained variance, percent of the explained variance, or proportion of 0.04. I did not find an easier way to do this, unfortunately, based on one model. But there is an easier way to get all of this if you're willing to do it hierarchically, like build your models in order and look at the change at each step. So I'll show you that in example 4b, because a lot of folks do it that way. So I repeated this process 2 more times, omitting age from this model to get its unique contribution and effect sizes, and then omitting education from the last one and getting those as well. So then all of those numbers are summarized in this table right here. So the total R square for this model is 0.29. If I add up the combinations of work class, age, and education that I just got, my total is only 0.2. Now, did I do the math wrong? Or is that expected?
Expected, there's overlap.
because of the overlap, yeah. Remember, R square counts what's in common, but none of the individual slopes gets credit for it. All right, so that's the Stata version.
Yay.
R, folks, I'm not forgetting about you.
So on
Question?
that model, that table you had up above,
Mhm.
that was actually you
I did this.
personally making that particular item. Would you recommend making that particular item for any study to make sure you have your items organized?
Not necessarily.
Maybe not to share, but just for you personally to use.
I probably would not do that in like a professional publication or results section, but for pedagogical purposes, I built this table to show how the pieces fit together.
Okay.
Because there's a lot of numbers all over the
Oh,
place.
yeah,
So
yeah.
like trying to combine that into something that is easy to understand.
Okay.
So it's like the SS effect is how much information those predictors were uniquely responsible for. And you know that by taking them out of the model and seeing how much the model sums of squares went down. So it requires fitting a comparison model without it and then seeing what happens. So SS residual is from the full model, SS total is from the empty model. So like this is how much of the total is the full model accounted for, and then each of the three components that we broke it down into. But their total sums of squares, or excuse me, total semi-partial eta square does not, too many damn words, does not add up to the total because of the overlap. All right, so our folks then, here's your version of the same problem with all 7 slopes. By the way, I learned the name of this thing, it's an inhibitor function.
Inhibitor.
Because
Interesting.
otherwise, it's like it would try to do math on this variable or something, and you don't want it to. So that's what it's for. I learned that from my graduate student who knows R much better than me. That's not hard to do. I'm still pretty bad at R, but I'm getting better.
But knowing the symbols helps.
It does, yeah. What does I stand for? I don't know. Inhibitor. So then this is the output from a function called supernova that prints the sums of squares table. So there's my F for the model, and this is my overall R square for the model as well. Then we get this is the output from a function that I wrote that combines what you get out of the summary with confidence intervals to stick those on the end. Unfortunately, it changes this into scientific notation for everything, and I haven't been able to fix that problem. So it's like, is this significant? I've did like e to the negative 0.01. Yeah, that p-value is 0.6, I think. So yes. So it's a little bit trickier to establish that. But you can just print the regular summary if you don't like my version. Then this is a function that I wrote that does the fixed effect sizes. So this goes in, grabs the t-value, and uses it to compute each of these things. So I printed the estimate and the p-value that is shown up above for reference, and then added all of these columns for specific effect sizes. And in your next homework that uses these, I'll tell you which one to use. Like, enter the partial R, or enter the, the D, or whatever. I don't want you to have to figure that out since there's so many choices. So then the model implied difference between middle and upper, that's GLHT. That's a separate function. So these numbers here, do you remember how these work? Yes, maybe? They're multipliers. So this is the spots in here that's separated by commas is the order of your fixed effects. So you're saying, don't do anything with the intercept. Take the slope that you estimated for this variable of 6 and multiply it by -1. Now take the slope that you estimated for this variable of 7.2 and multiply it by 1. So what that is doing is saying 7 minus 6. And then disregard all the other slopes. So that much, I wrote a summary function for that stacks on the confidence intervals to the end as well. And for whatever reason, these p-values are not in scientific notation. Like, seriously.
It is the same 6 points and minus E.
Yeah, so like this one isn't, but I don't know how to fix that. I'll work on that. Yeah. And then I made an effect size function because you have to go into that object in a different way. So I made a separate one to do that. So it's the same thing. So if you have a model parameter that you want an effect size for, then fixed effect sizes will get that for you. If you had to get it through a linear combination, then you want GLHT effect sizes. Those are the two functions that I wrote to do that. So then the lumping together part. I found a package that is, it's like LM helpers or something, and within that package, they had a way to easily get the f-test for 2 comparison models. I took that output and added additional effect sizes to it. So when all is said and done, what I'm doing here is taking these 2 slopes out of the model. I'm not even printing the model because all I need to do is get the results of the sums of squares and feeding that into here. So there's two arguments for this function. Reduced model is the one that doesn't have it, and then full model is the one that does. And then pred name is what do you want your output to say? This is 4. So, uh-oh. I just lost internet.
I was amused because there's no class for that model.
Yeah, no class. Hang on, my Zoom is starting back up again. Maybe. Eduroam is connecting. Please? Zoomers are like, what?
Yeah, early dismissal.
Yeah, no kidding.